If you're getting ready to do your holiday shopping at Sephora, Nike, or Neiman Marcus, make sure you head to Rakuten first. Rakuten helps you save big on whatever you're buying for the holidays. Getting gifts for friends and family? Get some cash back for yourself. Plus, save on festive home decor, party outfits, and that trip to see your fam. With Rakuten, you can earn cash back on top of the biggest sales of the season, so you get the most savings. And it's easy to use. Just start your shopping at Rakuten.com or use the Rakuten app, and you'll get your cash back payments through PayPal or check. Rakuten partners with over 3,700 stores. The stores pay Rakuten for sending them shoppers, and Rakuten shares the money with you as cash back. Join for free at Rakuten.com and get the Rakuten app. That's Rakuten.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 31, for broadcast on the 13th of March 2023. Coming up on SpaceTime, how the DART spacecraft ripped a hole in an asteroid. Japan's new H3 rocket explodes in flames on its maiden flight. And discovery of a nearby Earth-like planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
It's been revealed that NASA's DART spacecraft blasted over 1,000 tons of boulders and debris out of the comet Dimorphos when it crashed into the space rock in September last year. That impact also shortened the binary asteroid's orbital period by 33 minutes. These are among the latest findings reported in the journal Nature from the experimental DART, or Double Asteroid Redirection Test, to see if you really could use a kinetic impactor to deflect an asteroid on a collision course with the Earth. The target was a 163-metre wide rubble pile asteroid called Dimorphos, located some 6 million kilometres away. It's really just a small moonlet, orbiting a larger 780-metre wide asteroid called Didymos, which orbits the Sun in a highly elongated path between 1 and 2.3 astronomical units every 770 Earth days. By the way, an astronomical unit is the average distance between the Earth and the Sun. It equates to about 150 million kilometres. The entire collision event was captured by an array of telescopes around the world and in space, providing spectacular images of the collision and its aftermath. The last complete image of Dimorphos, taken by the Draco imager on DART, was just 12 kilometres from the asteroid, 2 seconds before impact. The image shows a tiny patch of the asteroid, just 31 metres across. The DART experiment also provided fresh insights into planetary collisions that may have been common in the early solar system. The Hubble time-lapse movie of the aftermath of the DART collision reveals surprising and remarkable hour-by-hour changes as dust and chunks of debris were flung into space. Smashing head-on into the asteroid at some 21,000 kilometres per hour, the DART impactor blasted over 1,000 tons of rock and dust off the asteroid. And the Hubble movie offers invaluable new clues about how all that debris was dispersed into a complex pattern in the days following the impact. This was over a much larger volume of space than what could be recorded by the camera on the Lucinda Cube CubeSat, which flew past the binary asteroid minutes after the DART impact. The study's lead author, Yang-Lang Li from the Planetary Science Institute in Tucson, Arizona, says the DART impact happened in a binary system and scientists had never witnessed an object collide with an asteroid in a binary asteroid system before. Li says the results were surprising. The Hubble movie shows 3 overlapping stages of the impact aftermath: the formation of an ejector cone, The spiral swirl of debris caught up along the asteroid's orbital path about its companion asteroid, and the tail swept behind the asteroid by the pressure of sunlight, which looked like a windsock caught in a breeze. The first post-impact images show debris flying away from the asteroid, moving with a range of speeds over 8 kilometers per hour. That's fast enough to escape the asteroid's gravitational pull, so it doesn't fall back onto the asteroid's surface. In fact, all this ejecta forms a large hollow cone with long stringy filaments. Then, about 17 hours after the impact, the debris pattern enters a second stage. The dynamic interaction within the binary system starts to distort the cone shape from the ejecta pattern. The most prominent structures now are rotating pinwheel-shaped features. The pinwheel is tied to the gravitational pull of the companion asteroid Didymos. Lee says this was unique for this particular incident because when he first saw these images, he couldn't believe these features and thought the images might have been smeared or something. But Hubble captures the debris being swept back into a comet-like tail by the pressure of sunlight on the tiny dust particles. This tail stretches out into a debris train, with the lightest particles travelling the fastest and furthest from the asteroid. The mystery is compounded later when Hubble records the tail splitting in two for a few days. No one's quite sure why this happened. A multitude of other telescopes on Earth and in space, including NASA's James Webb Space Telescope and the Lucy spacecraft, also observed the DART impact and its outcomes. This Hubble movie is part of a suite of new studies about the impact which are being published in Nature. In a separate study, Siegfried Egel from the University of Illinois calculated the momentum transferred to the asteroid on impact was far greater than what anyone had expected it would be. He found the momentum was significantly enhanced by the recoil created from the streams of particles produced by the impact. Egel and colleagues calculated the momentum transferred to Dimorphos as a result of the impact, known as the beta factor, and learned its displacement with respect to the primary asteroid Didymos. Egel says they could infer the shape of Dimorphos from images recorded by DART's Draco camera, but without knowing the mass it was difficult to estimate the momentum transfer onto Dimorphos. But after the impact they had new information, and that's made a big difference to their ability to make accurate calculations. See, they knew the impact changed the period of Dimorphos' orbit by 33 minutes, and this will all help with future simulations. Previously, they've tried to derive all their deflection predictions based on first principles. Problem is they didn't have a single actual data point to go off. Now they can compare which results match with which models. That'll give them a better understanding of how the impact happened, and they can therefore also make better predictions in the future. Egel's team ran Monte Carlo simulations using random combinations of variables, such as whether Dimorphos was more or less massive than Didymos. Because near-Earth asteroids are very diverse in their makeup, more tests like DART will be needed. The head of the Global Fireball Observatory, Dr. Ellie Sampson from Curtin University, says the data provides scientists with a unique insight into the characteristics of the asteroid and the physics of a kinetic impact. But at this stage, she says, we'll still need quite a bit of warning if we want to use a kinetic impactor technique to try and deflect an incoming asteroid in the future.
DART has been a really interesting mission. It's basically a fridge-sized spacecraft that's gone all the way out to hit this asteroid about the size of an Aussie football pitch. And what it was aiming to do was to try and change that asteroid's orbit. It was quite a clever idea, really. It's not just hitting one asteroid that's sitting out there on its own. It's actually hitting the moon of a slightly bigger asteroid. So it's what we call a binary asteroid system, where there's one large one and a smaller one that's going around it. And what it was aiming to do was to hit that smaller moon asteroid to see whether we could change its orbit around the bigger one. So the idea was that by hitting it head on, we would be able to slow it down enough so that its round trip around the bigger one was slightly shorter. So we originally thought that the predictions of how this was going to work and whether it would make an effect or not was looking at maybe around 7-minute change. So it would just take 7 minutes less to do that round trip. And what it actually did was it changed it by 33 minutes. So that's a lot more than we were expecting. And it's really interesting to be able to use that data to not only can we say that this, what we call the kinetic impact method, which is a very fancy way of saying, can we knock an asteroid off course by hitting it really hard with something going very fast? So not only have we been able to prove that can work to change an asteroid orbit, but we're actually learning a lot about the body itself. What's that asteroid made of? If we manage to change its orbit by a lot more than we were expecting, it must be made of either something slightly different than we were expecting or something else is going on.
I remember an experiment we did years ago in which we looked at the effect of an impactor on both a rubble pile asteroid and a monolith asteroid. The rubble pile asteroid was created just by lining up a whole bunch of rocks in a single pile, whereas the monolith was just one big single rock. We then fired a 30-06 bullet at both piles. The 30-06 went right through the rubble pile asteroid without really causing any serious damage, whereas it struck and knocked over, kicked a bit off the side of the monolith asteroid. That sort of told us that impactors may not be the best way to go against rubble pile asteroids. And we also saw that with the recent release of documents about the Bennu mission, where the spacecraft literally sank into the asteroid with its collector arm, leaving a 9-meter crater. If it wasn't for the fact that the OSIRIS-REx spacecraft had been pre-programmed to lift off after touching down, that space probe may have been lost inside the asteroid. So here are two rubble pile asteroids, but with very different properties.
Well, it's really interesting. When this DART mission went to that moon, we were able to get really high quality, high resolution images back from those asteroids as well. And the moon that it actually impacted, we can't see that very well from Earth. The only way we've actually been able to know that it exists and that it's there and what its orbit around the bigger one is just based on the reflection of light. So when we're looking out, we can see the reflection of the sunlight off the bigger asteroid. And when that moon basically goes in front of it, between us and the big asteroid, that reflection decreases. So we see less light as it's coming back at us. So we can start using those little, what we call dips in the light curve. So when we basically get an eclipse of that moon across there, we can get an idea of how it's going around the parent body. So we don't have a very good idea of what that surface looks like. We didn't know whether it was a rubble pile, whether it was monolith. And so we got some really nice high resolution images back from DART before it impacted and came to its end. But one of these papers actually does a really nice job of using those high-resolution images to recreate a very nice model of what that actually looks like. And it still kind of shows that it probably is still quite rubbly. There's loads of boulders all over that surface. And what's interesting, and like you were saying with that experiment, is that when we kind of expect rubble pile asteroids, we've kind of predicted that maybe something won't happen. Maybe it will just go straight through it. But what was interesting with DART was that actually the largest effect of changing its orbit wasn't actually DART hitting the body. It was actually when it hit the body, it actually ejected a whole bunch of material. So if you're punching into that fluffy asteroid, a whole bunch of material it's not being stuck together very well. It's just being held really by gravity. And that gets kicked back and you get a recoil effect. And that's actually why we reckon that you have much more of an effect on the change of orbit. It was just from all of that material that was ejected off and not the actual impact and explosion itself.
It's telling us that asteroids aren't simple things. They're not just chunks of rock floating around in space. There are all sorts of cohesion issues you've got to consider among the various subcomponents of the asteroid itself. And of course, you've still got things like the Yokosuka effect to worry about.
Yeah, and what's going to happen to those objects afterwards? That's something that was really cool to see, is that so we've obviously know a lot about meteor showers that come off of comets. So when a comet comes close to the sun, most of them are just made of ice and dust, and you start losing that ice as it comes to closer to the sun and leaves that lovely trail of dust and gas behind it that when the Earth passes through, we get the meteor shower. But cometary material is mostly just dust. But asteroidal material is a lot more solid and would be a lot more hazardous when it comes to Earth. And we don't have very many examples of what we call asteroid streams. So these trails of asteroidal material that are out there. And there's a few that have been predicted, or that actually when as you mentioned, with OSIRIS-REx going to Bennu, we actually saw boulders flying off of asteroid Bennu as it was basically spinning around. It was throwing things off and leaving a trail behind it of just what we call rotational, just because of the rotational effect. But we haven't really seen anything physically of where two asteroids might come into contact with each other and have a head-on collision where you end up with a large trail of debris as well. So being able to observe that from Earth, and we did with our telescopes, were actually able to observe this trail, this tail of debris, and it lasted for almost a month that we could see all of that material trailing off behind the binary asteroid system, which was really cool to see.
Yeah, I'd love to do a trip out to Phaeton to have a look at that rock comet, because it's basically an asteroid that's flipping boulders off it all the time.
Yeah.
And we go through the meteor shower that leaves
Gemini,
every December. Yeah, that would be interesting. So, and that's one that we get pretty close to on a regular basis.
That's a really nice idea. And the comet Phaeton is one of those interesting ones that's quite debated. Is it just an asteroid that's throwing material off, or is it actually a dead comet that used to be active, really highly active, and the material just left over? It is still coming, from that outer solar system. So it'd be really interesting to know what that's actually made of, and maybe one day we'll actually get a meteorite from Comet Phaeton, and that's something that we'd really love to be able to do with the Desert Fireball Network. So we have cameras across Australia looking for these really bright shooting stars and to recover the meteorites from them. And the ultimate goal for us would really be to capture a Geminid. So we haven't really seen any kind of come down close enough yet, but it's definitely possible.
One important question. I really love the name Didymoon rather than Dimorphos, and they changed it to Dimorphos. Speaking as a professional astronomer, what do you think about all that?
Didymoon.
Yes.
It's very cute. It does describe what it is a little bit.
How often are things the size of Didymos or Dimorphos likely to hit the Earth?
That's a really interesting question. So we have these objects, we have tons of material come to Earth every day. And most of it is small gas and dust, and we don't even see it. Some are slightly bigger, size of a grain of sand, and then we get a lovely meteor. But the larger objects that are meter-sized plus are much less frequent. But actually trying to understand how many come is really quite hard, and how many are actually out there that could impact the Earth. So we reckon we know about 95% of the kilometer-plus size asteroids, the ones that, if they impacted Earth, would cause global devastation and possibly even the end of civilization. But those are the really large kilometer-plus size objects, and we know we're about, like I said, about 95% of those objects are. There's probably, I think there's just over 800 that are tracked in the NASA database of near-Earth asteroids or hazardous near-Earth asteroids. But the smaller ones, it's really interesting. Back in 2013, there was just under a 20-meter size asteroid hit just over Chelyabinsk, Russia. I don't know if you remember that event.
Oh, yes.
It exploded. It exploded in the atmosphere, and the shockwave just tore out a whole bunch of windows and hurt a lot of people. It was 1,500 people were.
It was the damage from the smashed glass from the windows being broken through the shockwave, which caused all the injuries. The asteroid itself airburst, and the only segments they were able to find, allegedly, were found in a deep lake.
In the lake, yeah. And it's interesting to see, well, we class those 20-meter asteroids as not hazardous. But of course they are. They're not going to be the end of civilization, but they're still going to hurt people and cause quite a lot of damage. And we know probably around 4% of where those, actually less than 1% of the 20-meter asteroids, less than 1% of those that are out in outer space. When we get to larger ones like Dimorphos and Didymos, Dimorphos is around 150 meters across, so like I said, about an Aussie football pitch size. Probably around 4% of those objects. And they're still going to cause a lot of damage if they come to Earth. So trying to get a better idea of how many are out there and how many are actually impacting the Earth. For example, that Chelyabinsk event is estimated to maybe be one in every 50 years. But the uncertainty on that is actually quite large. That could be as frequent as one every 15 or as rare as one every 500. That's the uncertainty range we're looking at for the 20-meter asteroid.
The previous one would have been the famous event in Tunguska.
That was also a really big event, and unfortunately also hit just in Russia as well. And that one haven't actually got any pieces of that meteorite. That was a really interesting one where, the shockwave, you can see the effect of that shockwave by a whole area of trees that have been knocked down, and that area still hasn't recovered.
2,000 square kilometres of trees.
It was a very large area, and if that was over a populated area today, that would definitely cause regional devastation.
Yes, it literally lit up the skies a third of the way around the planet.
These things are amazing, and so that's what we're trying to get at with the data from the Desert Fireball Network as well, is just trying to get an idea of not just recover the meteorites, but observe the orbits of these objects coming in, figure out where they're coming from, and are there any areas of the solar system we should be pointing cameras at that are maybe more hazardous than others. So that's something that we're working on and trying to get a better understanding of the what we call the impact flux. How often do they hit?
That's the head of the Global Fireball Observatory, Dr. Ellie Sansom from Curtin University. And this is SpaceTime. Still to come, Japan's new H3 rocket explodes in flames on its maiden flight, and a newly discovered nearby Earth-like planet. All that and more still to come on SpaceTime.
Make their Christmas unforgettable with goat guns. Looking for the perfect gift for your husband or man who is a gun lover? Look no further. Goat guns are the greatest gift of all time miniature gun models. They are the perfect blend of quality and detail. From pistols to rifles, there's a goat gun for every collector, history buff, or gamer. Whether for display or for a fun collecting hobby, goat guns will bring joy and excitement to him. Surprise your loved ones this Christmas with a goat gun, the ultimate gift that won't disappoint. Shop at goatguns.com.
The maiden flight of Japan's new H3 rocket has ended in a crash and burn. The 60-metre-tall launch vehicle blasted off brilliantly from the Tanegashima Space Center south of Kyushu, with the first stage performing nominally. However, following MECO, that's main engine cutoff, and then stage separation, the second stage failed to ignite, and that forced officials at the Japanese Aerospace Exploration Agency JAXA to order a self-destruct at an altitude of about 300 kilometres. Debris from the now destroyed rocket fell into the ocean east of the Philippines. The cause of the failure in the second stage is still being investigated. The incident comes in the wake of the first launch attempt last month being scrubbed after main engine ignition when the strap-on solid rocket boosters failed to ignite. A second launch attempt was postponed by 24 hours due to bad weather. This mission was carrying the new ALOS-3 surveillance satellite, which was equipped with infrared sensors to detect missile launches from countries likely to be hostile to Japan. The H3 rocket development has been more than 2 years behind schedule, mainly because of engine design issues. Once it's perfected, the H3 will replace Japan's current H2 workhorse rocket, providing greater flexibility, more frequent launches, and a more economical launch as well. This is SpaceTime. Still to come, a newly discovered nearby Earth-like planet has scientists intrigued. And later in the science report, the World Meteorological Organization warns that an El Niño event may develop in coming months. All that and more still to come on SpaceTime. Astronomers say a newly discovered exoplanet similar in size to the Earth could be worth searching for signs of life. The intriguing world is orbiting the habitable zone of a red dwarf star known as Wolf 1069, which is located just 31.2 light-years away in the constellation Cygnus the Swan. That makes this system a veritable cosmic neighbour. The habitable zone is the area around a star where temperatures are warm enough for liquid water essential for life as we know it to exist on a planet's surface. And this planet, Wolf 1069b, orbits its host star every 15.6 Earth days, placing it well and truly within the habitable zone. The findings, reported in the journal Astronomy and Astrophysics, indicate that there are no additional planets greater than one Earth mass with orbital periods less than 10 days within this planetary system. Wolf 1069b is now considered the sixth closest known Earth mass planet within the conservatively defined habitable zone. It comes after Proxima Centauri b, Gliese 1061d, Tiergarten star C, and Gliese 1002b and c. The study's lead author Diana Kosakovsky from the Max Planck Institute says the newly discovered planet is very likely a rocky world like the Earth and may also have an atmosphere. That makes this world one of the few promising targets to search for signs of life-friendly conditions and biosignatures. When astronomers search for planets outside our solar system, that is exoplanets, they're especially interested in Earth-like planets. Of the more than 5,000 exoplanets that have been found so far, only about a dozen or so have Earth-like masses and populate in the habitable zone. Because the host star is relatively cool, being a red dwarf, Wolf 1069b only receives about 65% of the incident radiant heat which the Earth receives from the Sun. But still, that's enough. These special conditions make planets around red dwarf stars like Wolf 1069 potentially friendly to life. However, there's still lots of debate among scientists as to whether or not red dwarf stars are likely to host habitable worlds. See, there are both positives and negatives here. These stars are smaller and cooler, but far longer lived than stars like our Sun. However, they also tend to erupt with powerful stellar flares during their youth. These flares could potentially strip the atmosphere off any closely orbiting planets, irradiating the surface and killing any life. And being so close to its host star suggests that the planet is tidally locked with the same side always facing the star, and the opposite side in eternal night. It's the same reason why the same side of the moon always faces the Earth. However, according to existing knowledge, it's quite possible that Wolf 1069b has formed an atmosphere. Now, under this assumption, climate models show its temperature could have increased to plus 13 degrees, and that's good enough for a very comfortable habitable lifestyle. So under these circumstances, water would remain liquid and life-friendly conditions could prevail. But again, it all comes down to whether or not the planets retain an atmosphere. An atmosphere is not only a precondition for the emergence of life from a climatic point of view, it would also help protect Wolf 1069b from high-energy electromagnetic radiation and stellar wind particles that would destroy possible biomolecules and irradiate the surface. The planet itself was discovered using radial velocity measurements, the so-called wobble method, that is, detecting the wobbles of the host star caused by the gravitational tug of the orbiting planet. As the planet moves towards the far side of the star, its gravity pulls the star away from our point of view ever so slightly, and that causes the star's light to shift towards the red end of the spectrum as the light waves are stretched. And as the planet moves around towards the star's near side, it pulls the star ever so slightly in our direction, thereby shifting its light towards the blue end of the spectrum as the light waves are compressed. It's the same Doppler shift effect you would have noticed when a train approaches and then passes you at a station. As to whether there really are any trains, or life for that matter, on Wolf 1069b, only time will tell. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization has warned that an El Niño event may develop in coming months. The warning follows 3 consecutive years of La Niña weather patterns, which brought cooler temperatures and extreme rainfall events to much of Australia. But the WMO says while the return of El Niño is considered likely, before we get there, we're more likely to have periods of more neutral weather conditions, especially during the March to May period. The chances of El Niño developing, while low in the first half of the year, just 15% between April and June, gradually increased to 35% between May and July. But it's the longer-term forecasts from June to August which indicate a much higher 55% chance of El Niño developing. But it's still all subject to high uncertainty associated with predictions at this time of year. A new study has shown that the chemicals in bushfire smoke can enhance the activation of molecules that destroy ozone. The findings, reported in the journal Nature, increase concerns that more frequent and intense bushfires could delay ozone hole recovery in a warming world. Previous research has shown that smoke from the 2019-2020 Black Summer bushfires in Australia changed the chemical composition of the upper atmosphere, and that also included a decline in the level of ozone. But the new research looks at how this might be happening. Scientists found the smoke enhances the activation of chlorine radicals, and they're molecules that can destroy ozone. China has further cemented its position as the world's biggest greenhouse gas emitter following Beijing's approval of the largest expansion of coal-fired power stations since 2015. A new report by the Center for Research on Energy and Clean Air shows China's rush to build new coal-fired power stations meant that authorities granted permits for 106 gigawatts of capacity across 82 locations in 2022. That's the highest number in 7 years, and 4 times higher than 2021. Preliminary data has already suggested that China's carbon dioxide output rose by 1.3% last year compared to 2021. And in 2021, China released some 11.47 billion metric tons of carbon dioxide emissions. That's more than a quarter, 27% in fact, of all the world's CO2 production. China is now easily the world's largest emitter of carbon dioxide emissions, producing roughly twice the CO2 emissions of the United States each year and producing more greenhouse gas emissions in one day than Australia does in a whole year. The increase was primarily due to a record 3.3% rise in coal consumption and came even as output from steel and cement production, two of the largest users of fossil fuel outside power production, fell significantly. Well, after examining some 510 reports of so-called unidentified aerial phenomena, or UAPs, things we used to call UFOs or unidentified flying objects, the United States Office of the Director of National Intelligence has concluded that the observed increase in UAP reporting rates is partially due to a better understanding of the possible threats that UAPs may represent, either as a safety or flight hazard, or as a potential adversary collecting platform, such as China's recent spy balloon. And it's also partially due to a reduced level of stigma surrounding UFO reporting. Initial analysis of 366 reports found that 26 were characterized as unmanned aerial systems, in other words, they're drones. A further 163 were balloons, and 6 were attributed to clutter. The rest simply lacked enough detailed data to be able to draw any sort of proper conclusion. Tim Mendham from Australian Skeptics says through the whole report there was no mention of aliens from another planet.
This is about unidentified aerial phenomena, which is the modern-day word for UFOs. And it's a study that was put out by the US Office of the Director of National Intelligence. Now, as you know, the Pentagon and people like that are taking sort of sightings of unknown aerial phenomena a bit more seriously and looking into them, and they're collecting data on sightings. What they're saying is that they're getting more examples of these sightings coming in, possibly because there's less stigma associated with seeing these things. So therefore, that would be encouraging people to report what they have seen. It might also be because there's more stuff up there, and what they're getting is
lots of Chinese weather balloons.
Chinese weather balloons is actually seriously one of them. It's part of the topics, but they've almost doubled the number over the last couple of years of what they've been looking at, and they're obviously not looking at every sighting, but of the ones they look at, a number are characterised as unmanned aircraft systems, which is drones and things like that. There's a lot of drones out there, not necessarily huge looking like UFOs, but then what do UFOs look like? Even higher percentage are balloons or balloon-like entities, and there we get into your Chinese weather balloons and things. And there's a number that can be attributed to clutter, which is basically, sort of noise and all sorts of things like that on whatever reason. It says there's a lot there that you just do not know what they are. That's why they're unknown, funnily enough. And this is what encouraged a lot of people with the last Pentagon report, that there's a high percentage of unknowns. But that's as far as the Pentagon went, which is fair enough. They're unknowns. They're unidentified aerial phenomena, so they should be unknown. Otherwise, they'd be identified aerial phenomena. So the Pentagon said that there's a lot of those around that people said instantly, flying saucers or whatever, sort of alien extraterrestrial flights, etc. But no, they're just
black ops and
Or that as well, yes. Yeah,
the lens, things like that.
Yeah. Now, the trouble is the unknowns, and that's as far as you can go. And they've received a lot of unknowns, or things that they can't identify. And it's not part of a conspiracy to cover up what is known. No, they're unknowns. And in this latest report of this increased number from the Director of National Intelligence, there is no mention of aliens. So what they're saying is that these are things people have seen, and a fair percentage we cannot identify. Perhaps there's not enough information. Perhaps the evidence is pretty poor, which it often is with people filming UFOs. I keep trying to figure out why everything is so badly filmed, or that there are very mundane explanations for what these things are. So we will continue to see this. We will continue to see large numbers of sightings because there's stuff to cite, and we will continue to have people who will claim because it's unknown, it must therefore be X, which means extraterrestrials or other nations' sort of operations, or even say American sort of secret aircraft operations, etc. So it's an ongoing issue, but basically don't take it, say the Pentagon is, or even this intelligence office is saying these are extraterrestrials. They're not. They're saying they're unknown. And sometimes in the skeptical world you get that very frustrating result, which is unsatisfying to anybody, to say, sorry, just don't know.
That's Tim Endham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.